All right, this one is short, and the reason why it's short is because they took a lot of the organic off the AP exam when they did the revision. This is a pretty cool problem for ice charts that's not too tough. And so here we go. The compound butane, if you remember, but means four, C4H10, occurs in two isomeric forms, N-butane, which stood for normal butane, and isobutane, which is actually, took it off, don't worry about it. Both compounds exist as gases at 25 degrees Celsius in one atmosphere. The two isomers exist in equilibrium as represented by the equation below. And what isomers are is they have the exact same condensed formula. They both have C, 4 carbons and 10 hydrogens, but they're just structured different. Um, and so here's the isomer and butane gas and isobutane gas that goes back and forth. And the equilibrium constant is 2.5 at 25 degrees. Suppose a zero point zero 0.01 mole sample of pure butane is placed in an evacuated 1 liter rigid container at 25 degrees. Write the expression for the equilibrium constant. This is actually a very easy problem because K, and you don't have to have the C, but it's the concentration of the isobutane. Um, and, both of them are C4H10, so we just have to write out the word over the concentration of the N-butane. This is actually a very easy problem because everything's to the first power. Um, we wouldn't want to do something like this. It's the concentration of the C4H10 over the concentration of the C4H10, because what isomers are is they have the exact same um, condensed formula but different structures. Normal butane is when the carbons are in a row, and isobutane is when you have three in a row and one dangling here. But they still are, if I put the H's on, they still are both C4H10. And so that's why we're going to use the words, probably more information than you need. B, calculate the initial pressure in the container when N-butane is first introduced. And so this is interesting. So I'm just going to go back. Notice this is a G and this is a G. And when they ask about pressure, um, and everything's a gas, this is a gas law question. So if you just remember that PV equals nRT, this is the Perv-Nerd equation, and that they want the pressure. And so pressure is nRT over V. And if you go back to the problem, they said that this was 0.010 moles. They gave you that. Now, if you look online for the scoring guidelines, again, they went one more sig fig when they did the revision. They will probably have 0.0821 here. Um, but the new formula sheet has this listed as R. And then they told you the temperature, so they told you the volume was 1 liter, and they told you the moles was 0.010 moles, and they told you that the temperature was 25 degrees Celsius, which is 298 K. And so I'm running out of room here, but just pretend N, R, and T are all on the top, so then just 298 K. And then volume is the reciprocal, so 1 over 1 liter. And so interestingly enough, mole on the top, mole on the bottom, liter on the top, liter on the bottom, K on the bottom, K on the top. We're solving for pressure. Everything's canceled except atmospheres. And if you pop that into your calculator, you should get 0.24 atmospheres. The reason why I'm keeping 2 sig figs is this guy has 2. So remember, this is significant rule 1. This is significant. It's a final 0 after the decimal point. These zeros aren't sandwiched, and they're not final zeros, so they're insignificant. This guy has 4. 1, 2, 3. That's sandwiched. This guy has 3, and this guy has 2. And so 2 of them have 2, so we only get 2. And then here's why I picked this problem. I really, really, really like this problem because of this way. N-butane reacts until equilibrium is established at 25 degrees. Calculate. And so this is an ice chart. So what you have is you have N-butane, which is normal butane. And that's in equilibrium with isobutane. No, yeah, isobutane. They're both butane. They're just, and then here's, and they want molar concentration. So this is a Kc, not a Kp. So ICE, I call them ice charts. I think Higgins called them rice charts, same difference. Now, this has to be molarity. Well, we have 0.010 moles over 1 liter. Thank God the math is easy. The molarity is also 0.010 because 0.010 divided by 1, and this is 0. And then this is going to go up because you can't go down from nothing. And this is going to go down. And so then this is this, because remember, drawing a line here, this plus this gives you equilibrium, what you started with and the change. And so what happens is, and this is actually very easy to solve. Hopefully by now we've done enough review that you know how to use your solver. But Kc, we did this in A, is the concentration of the isobutane over the concentration of the normal butane. Everything's to the first power, so this isn't too bad. They told you in the problem that Kc was 2.5, and up in this chart, isobutane is defined as X, and N-butane is defined as 0.010 minus X. And this is actually very easy to solve algebraically. You could, if you wanted, use your solver. But you know, you could do whatever you needed to do this time because it was easy enough. I just solved it. So what I did was, for whatever reason, I got to grab my pen again. I take this cross, so 1 times X is X. And then I take this cross, but I can't forget the distributive law. So 2.5 times 0.010 is 0.025 minus 2.5x, and then I'm going to add 2.5x to both sides, and I end up with 3.5x equals 0.025. And by the way, I'm not worrying about sig figs till the very end. All right, so I'm going to grab this and extend the page some more. And then to solve for x, you divide both sides by 3.5, and x comes out to be rounded to 2 sig figs, 0.0071 molar. Now, the question was, calculate the molar concentration of each species. Well, if you go back up here, we defined the concentration of isobutane as X. So we know that that's 0.0071. And then N-butane is going to be 0.010 minus 0.0071. So when I come down here, I need to write that the concentration, so the concentration of the isobutane, which your ice chart defines as X, is 0.0071 molar. But the concentration of the N-butane is 0.010 minus X. And if you do that on your calculator, and this has 3 decimal places and this has 2, the best answer is 0.003. Sorry, I said that wrong. I have no idea what I just did there. All right, let's go up here. Oops, I know what I did. I shaded this. Grabbing a different color pen. Remember now, when you add and subtract, you count decimal places. So this has 3 decimal places, or here's what a math teacher says. This is good to the 1,000th. This is good to the 10,000th. So our answer is only good to the 1,000th. This has 4 decimal places, and so our answer can only have 3. 1, 2, 3. And so the best answer to this problem for the concentration of the N-butane is, oh gosh, you are being just fussy, M, so 0.003 molar. All right, that's it for that one.